This is the numerical problem set on projectile motion. First question is the position vector of the particle changes with time according to the relation RT equal to 15t square I plus 4 minus 20t square j. What is the magnitude of the acceleration in meter per second square at t equal to 1? Given position vector R, which is a function of time, is 15t square, unit vector I along the x-axis plus 4 minus 20t square j is the unit vector along the y-axis. We know that velocity is given by rate of change of position vector. So we have to differentiate, and it is 15t square I plus 4 minus 20t square j. Differential of sum is sum of differential, so it will be written as differential of 15t square I plus differential of 4 minus 20t square j. This will be equal to, we will take constant terms out of the differential, and also I and j are directions, so they will be also taken out of the differential. We will have 15 into differential of t square I plus differential of 4 minus 20 into differential of t square into j. Differential of t square will be 2t, so it is 15 into 2ti plus, this is constant term, differential will be 0, and this is t square, so differential will be 2t. So we will have minus 20 into 2t j. This will be equal to 30t I minus 40t j. And acceleration is the rate of change of velocity. So we will differentiate the velocity with respect to time. It will be 3t I minus 40t j. So it will differential 30 into differential of t is 1 and i's direction will remain same, minus 40 into this differential of t will again 1 and then direction j. So acceleration will be 30i minus 40j. This is the ax and 40 is ay. Therefore, magnitude of the acceleration will be square root of ax square plus ay square. This will be equal to square root of 30 square plus 40 square, or it will be equal to 900 plus 1600, that is equal to square root of 2500, and it will be equal to 50 meter per second square. Hence option A is the correct option. Second question is, the position of particle as a function of time is given by xt equal to at plus bt square minus ct cube, where a, b, c are constants. When the particle attains zero acceleration, then velocity will be. It is given that position is given by xt equal to at plus bt square minus ct cube. So velocity as a function of time will be differential of position with respect to time. So we will write differential of at plus bt square minus ct cube, and it will give differential of sum is sum of differential. We can write differential of at plus differential of bt square minus differential of ct cube. Constant terms can be taken out of the differential, so it is a into differential of t plus b into differential of t square and minus c into differential of t cube, and their differential will be, formula is differential of x raised to the power n is equal to nx n minus 1. So we will have, it is a, differential of time is 1 plus b into differential of t square will be 2t plus minus c into differential of t cube will be 3t square. So it will be a plus 2bt minus 3c t square. Similarly, we can further find the acceleration by differentiating the velocity with respect to time. So we will have differential of a plus 2bt minus 3ct square, and proceeding as above, we will have age constant, so differential will be 0 plus 2b into differential of time will be 1 plus minus 3c, and differential of t square will be 2t. So we will have 2b minus 3c, that is 3 into 2, 6 ct. As per question, we have to find the time when the acceleration is 0. So to have 0 acceleration, we will put 2b minus 6ct equal to 0. This implies that 6ct is equal to 2b, or t is equal to 2b by 6c. These two get cancelled, so t will be b by 3c. And we have to find the velocity at that time. So velocity will be a plus 2b into t. T is b by 3c minus 3c into t square, that is b by 3c whole square. We will use this formula here. So this will be equal to a plus 2b square by 3c minus 3c into b square by 3c whole square. This 3c get cancelled, and we will have a plus 2b square by 3c minus b square by 3c, and finally it is a plus b square by 3c. So option C is the correct option. Third question is, a projectile is given an initial velocity of I plus 2 j meter per second, where I is along the ground and j is along the vertical. If g equal to 10 meter per second square, then equation of its trajectory is. Suppose on the ground from a point a projectile is projected with velocity u at an angle of theta with the horizontal. So this projectile takes a parabolic path. Now we resolve this velocity in two perpendicular components. One is along horizontal, it is ux, and another is uy. We are given that velocity is I plus 2j meter per second. So it can be written as uxi in its components plus uyj. Therefore, ux will be equal to 1 meter per second, and velocity in y direction will be 2 meter per second. There is no acceleration in horizontal direction, so ax will be 0, and acceleration in y direction will be minus g, that is equal to minus 10 meter per second square, because acceleration due to gravity is acting downward. Therefore, to find the equation of trajectory, we have to relate the x and y. Using the equation of motion, which is s equal to ut plus half a t square in both x and y direction. So along x-axis we can write that this projectile after time t reaches at a point B, which is at a distance x from A in horizontal direction and at a distance y in vertical direction. So to relate this, we have to find x. X will be equal to initial velocity is ux, so it is ux into t, and acceleration is 0, so it is half into 0 into t square. So this will be simply x equal to ux is 1 and time is t, therefore x equal to t. This is our equation number 1. For vertical direction, we will write y equal to uyt plus half ayt square. Now substituting the values, we will have y equal to uy is 2 into t plus half, and ay is minus g, that means minus 10 into t square. So we will write y equal to 2t minus 5t square. This is equation number 2. Now put value of t from 1 into equation number 2, and we will get y equal to 2 x minus 5x square. This is the relation of x and y and gives the trajectory. So our option B. Fourth question is, two guns A and B can fire bullets at a speed of 1 km per second and 2 km per second respectively. From a point on the horizontal ground, they are fired in all possible directions. The ratio of maximum area covered by the bullets on the ground fired by the two guns is. It is the problem related with the range of the projectile. Suppose from point A on the ground, a body is projected with speed u at an angle of theta with the horizontal, and the projectile takes the parabolic path and reach at a point B. On resolving the speed, there are two components. One is horizontal ux and component along y direction is uy. This ux is u cos theta and uy is u sin theta. There is no acceleration in horizontal direction, so ax will be 0 and ay will be equal to minus g because acceleration due to gravity is acting downward. First, we will find the time of flight. It is the period for which the projectile remains in air when it moves from A to B. So we will use equation of motion s equal to ut plus half at square for vertical direction. In vertical direction, while object move from A to B, that displacement is 0, so it is 0 equal to velocity in vertical direction is uy and time taken to reach from A to B, suppose capital T, plus half ay into t square. Substituting the value, it will be 0 equal to uy is u sin theta into t minus half into g into t square. Here t is common, so equation will become 0 equal to u sin theta minus half gt into t. This implies that either t equal to 0 or u sin theta minus half gt is equal to 0. This t equal to 0 is not allowed because there will be some time elapsed between point A to B. So we can write u sin theta minus half gt equal to 0 or t will be equal to 2u sin theta by g. This is the formula for time of flight. Now we will find the range of projectile r, which is the distance between A to B. So range will be equal to horizontal speed, it is ux, and the flight time t. This is equal to u, this ux is u cos theta into flight time is 2u sin theta by g. So we will write it is u square into sin 2 theta by g because 2 sin theta cos theta is sin 2 theta. And this r will be r max and it will be equal to u square by g for sin 2 theta equal to 1 or theta equal to pi by 4 or 45 degree because sin theta has the maximum value which is 1. Therefore, maximum range is equal to u square by g for speed u. This implies that maximum range is proportional to the square of the speed of the projectile. Now we have to find the covered areas. Area depends on the range and it will be equal to pi r square where r is the range. So maximum area will be proportional to the r max, that is the maximum range square, and range is proportional to u square, so we can say it is proportional to u square square or u raised to the power 4. Therefore, maximum area covered by projectile 1 divided by the maximum area covered by projectile 2 will be equal to speed of projectile 1 raised to the power 4 by projected speed of projectile 2 raised to the power 4. u1 is 1 and u2 is 2. So it is 1 by 16. Hence option B is the correct option. Fifth question is a true-false question. A projectile fired from the ground follow a parabolic path. The speed of the projectile is minimum at the top of its path. So suppose the parabolic path of a projectile is drawn here. Here object is projected at a point A and it strikes after some time at point B. And the path is parabolic and the top point is say C at a height h from the ground. And as per statement, at this point C, the speed will be minimum. From the conservation of the mechanical energy, we know that kinetic energy plus potential energy is constant. And at highest point, this potential energy will be maximum. So at highest point, then kinetic energy will be minimum. And for minimum kinetic energy, speed will also be minimum. Hence, this statement is true statement. Sixth question is the trajectory of a projectile in vertical plane is y equal to ax minus bx square, where a, b are constants and x and y are respectively the horizontal and vertical distances of the projectile from the point of projection. The maximum height attained is, and the angle of the projection from the horizontal is. Here, path of the projectile is given y equal to ax minus bx square. Here y is a function of x. So slope of tangent at a point on the trajectory is given by tan theta, and it will be equal to dy by dx. So slope tan theta will be equal to dy by dx. It will be equal to differential of ax minus bx square. So it will be differential of ax minus differential of bx square. A and b are constant, so it is a into differential of x is 1 minus b into 2x. Therefore, slope of the tangent at a point on the projectile path will be a minus 2bx. If we draw a figure for the projectile motion, it is a parabolic path. At a, projectile is projected with speed u at an angle of theta. Suppose we take an arbitrary point on the projectile path, say P, which have the coordinate x and y, means its distance along the horizontal axis is x and along the vertical axis is y. At the maximum height of the projectile path, say at point C, the slope of the tangent will be 0. So at C, that is maximum height, slope is equal to 0. This implies that a minus 2bx equal to 0 or x equal to a by 2b. So distance of the point C along the horizontal is x equal to a by 2b. And for this, maximum height will be y max, that will be equal to a into, and substituting the value of x, it will be a by 2b minus b into a by 2b square. So it is equal to a square by 2b minus b into a square by 4b square. 1b get cancelled, so it is equal to a square by 2b minus a square by 4b. So it will be equal to a square by 4b. So maximum height attained is a square by 4b. And now we have to find the angle of projection. At angle of projection, slope will be, because angle of projection is theta, so at point A, slope will be tan theta, and it is equal to dy by dx. That is equal to, we have find tan theta is a minus 2bx. And at point A, x equal to 0. So we substitute the value of x equal to 0. We will have slope tan theta equal to a. That means angle of projection theta is tan inverse a. So angle of projection from the horizontal is tan inverse a. This is the answer. Seventh question is, a plane is inclined at an angle of alpha equal to 30 degree with respect to the horizontal. A particle is projected with speed u equal to 2 meter per second from the base of the plane, making an angle of theta equal to 15 degree with respect to the plane as shown in the figure. The distance from the base at which particle hits the plane is close to. Take g equal to 10 meter per second square. Here we will take the reference direction x along the inclined plane and y along the perpendicular to the inclined plane, and the component of u along the x-axis will be ux and perpendicular to the x-axis it will be uy. Similarly, in case of the acceleration due to gravity is acting downward, so we make its two perpendicular component. Angle is theta, this is the alpha, that is 30 degree. So component in vertical direction will be g cos alpha, and in horizontal direction it is g sin alpha. Therefore we can write that horizontal component speed is u cos 15 degree and uy is equal to u sin 15 degree. Because u is 2 meter per second, so we can write it as 2 cos 15 degree and 2 sin 15 degree. Similarly, acceleration along the x-axis is minus g sin alpha, that is equal to minus 10 into sine of alpha is 30 degree. And ay will be equal to minus g of cos alpha, that is equal to minus 10 of cos 30 degree. Now using these equations, we can find time of flight. That means how much time for which projectile remains in air. For time of flight, we will use equation of motion that is equal to ut plus half at square in vertical direction. In vertical direction, we will use net displacement is 0 because projectile start from the inclined plane and strikes again at the inclined plane. So it will be 0 and velocity in vertical direction will be uy and time of flight is say capital T plus half into ay into t square. This implies that t is common. So remaining is uy is 2 sine 15 degree plus half into ay is minus 10 cos 30 degree into t square. So t is common, it remains t and it will be equal to 0. This implies that t equal to 0 or 2 sine 15 degree minus 5 cos 30 degree into t will be 0. This t cannot be 0 because there is some time elapsed between the time at which it is projected and when it strikes the inclined plane. So t cannot be 0, therefore 2 sine 15 degree minus 5 cos 30 degree into t will be 0, or we can say t is equal to 2 sine 15 degree by 5 into cos 30 degree. This is our equation number 1. Now to find the range. Range can be calculated again with the equation of motion s equal to ut plus half a d square. To find the range, we will use the x-axis motion and it will be given by this range r is equal to horizontal speed ux into flight time t plus half into acceleration along x-axis into t square. And now substituting the value ux is 2 cos 15 degree, flight time is 2 sine 15 degree by 5 cos 30 degree plus half ax is minus 10 sine 30 degree and then t square, and t square is 2 sine 15 degree by 5 cos 30 degree whole square. And now we solve it. It will be equal to this is 2 and this is 2 into 2 4 sine 15 degree cos 15 degree by 5 sine cos 30 degree plus, and this plus minus minus, and then 10 by 5 10 by 2 this will give 5 sine 30 degree into 4 sine square 15 degree by 25 into cos square 30 degree. This will be equal to this sine 15 and cos 15 can be converted into the sine 30 degree using the formula sine 2 theta is equal to 2 sine theta cos theta, and here sine square theta it can also be written as 1 minus cos 2 theta by 2. So we can use these formulae and get 2 into sine 30 degree by 5 into cos 30 degree minus 5 into sine 30 degree by 25 cos square 30 degree into, and here we will have this is 2, remaining is 2 sine square 15 degree, and it can be written as 1 minus cos 30 degree by 2. Now we have the formula that sine 30 degree equal to 1 by 2 and cos 30 degree is equal to root 3 by 2, and substituting and on solving we will find that answer is approximately 20 centimeter. Hence option B is the correct option.